Sauce here. This is a video lesson for Python programming, the Pickle module. I recommend pausing on occasion to practice. The module named Pickle offers a way to easily save information. When we use it, we also import OS, which is another module, which helps us manage the operating system. We will be using the OS module and a module called Pickle. So we'll import them at the top of the file. We will be making files to store or pickle data. Before we make a file, we need to know where on our computer drive the operating system is currently focused. This place is called the working directory. And its location within the structure of your drive is called its path. We find the path with function and assign it to a variable. So I'm going to write a line of code and set the variable path. Doesn't need to be, the variable doesn't need to be path, but this describes what the value of the variable is going to be. And we get the current working directory from a function in the OS module. So we need to write path is equal to os dot get cwd. CWD stands for current working directory. And we can print the value of path and run our program to observe where on our computer the current working directory is, what the computer is looking at as far as where it's going to place a file once the file is created. Now, the current working directory ought to be the same directory that I loaded or started the program that I'm writing now. It was the folder that I was using right before editing this file. If I save and run, I can see that my current working directory is users tsosmic desktop Python class because it's the Python class folder that I started writing this program. And that will be just a fine place to create a file. The file that I create will be then put in that location. The path is going to be different for different computers. Next, we will want to open a file at that location. The location of where we open a file can be modified by modifying the path. But for now, we will open a file at the current location. The function that opens a file will also create it if it didn't already exist. We also assign the file to a variable. It is the following example. The variable TOF stands for the open file. So we're going to write a line of code and we're going to set to this variable TOF, which stands for the open file, equal to a call to the open function. We still have to write the argument of the open function, but before we do, I want to show that in my folder, the contents of the folder that is the same as the path location that I just discovered, the contents can be seen here. I'm going to make a file called data file, and I want to show that the contents does not include, this is alphabetically listed, does not include a file called data file yet. So we'll complete the argument of the open, and the open function takes two strings. The first string is going to use the path. I'm going to use a placeholder string, and that %s will be replaced with the value of path in just a moment. What comes next is the name of the file. I'm going to call data file, and it's going to be a .py. It'll be a Python file. In the string, I need to replace the string symbol with the path value. So this first part of the argument is a string, which is the path or the location of the file, and then also the file's name. The second part of the argument is the mode that I'm going to open the file in. There are many modes. We'll make use of two. WB stands for write binary. So this file will be used to write, only write, not to read from, but to put information into, and it'll be a binary mode. And the comment, after running this line of code, the file is now open. We can check to see that it exists in our computer by looking at the location of the path. The argument of open has two parts. The first is the location and name of the file concatenated into a single string. So this whole line here creates a single string out of the path and the file name. Notice how the variable path was used. The name of the file is datafile.py. The second part of the argument is the mode the open file is in. WB stands for write binary. The other mode we will make use of is RB for read binary. Let's save and run our code. And we assume our code in opening a file created the file if it didn't already exist. So if I go to the path, I'm looking for a file called datafile. And we can see that it put it in alphabetical order. Datafile exists now. Continuing on. With a file open in write mode, we can put information into the file. We are focused on using Pickle, the Pickle module, a very simple way to put information into files. So the manner by which we will place information into the file will rely on the dump function. Dump is a function that belongs to the Pickle module. And we do this by referring to the Pickle module, the dump function within it, and what we are going to dump is a simple string, hello files. And the second part of the dump function is the file that we're dumping it into. We opened that file and assigned it to the variable TOF. So by putting TOF here, that is the file in which we are going to dump this string into. And it's that easy. A string was encoded and written to the file given in the second part of the argument, the TOF. If we are done, we need to close the file so that malicious programmers don't use it as a portal to dump problematic code. To finish this process of using the file, we need to refer to it and then use the close method. This line of code will close the open file. If we save and run, this process now repeats. This time the file existed so that when we opened it, it was already there. It didn't create a second one, but it opened that file and put the string into it. If we went to the file itself and we took a look at its contents, if we thought of it as a Python file and edited it and opened it, it would ask us to specify the file encoding because the pickle dump function encodes things before it writes them. It does so for efficiency's sake. So we're not going to see the hello file written here. It's written in a way that Pickle uses to make file management easier. But we can check the file. Is there something in it? There was, but when we opened it up, it wanted to check what we wanted to do, if we wanted to decode or change it, and I didn't want to change the contents of the file, so I said cancel. We can get the information out by a similar process. We will open the file in read mode this time and get the information with load and assign it to a variable, close the file, and print what we got. So looking at the file itself, since it's been encoded, doesn't help. But if we wanted to check out and use what's in the file, we can do that within our program. So we're going to use a similar process. We're going to call the open file TOF again, and we will use the open function. The string will be the same. We need the path represented as %s. The name of the file is data file. We will complete this string by supplying that %s with the path, the value of path, the same location that we got before. But the mode will change, so the second part of this argument is RB for read binary. With that open file, we're going to load the data from it. And when we load the data, we're going to need to store that data in a variable. So I can create a variable, anything I want. I'm going to call it data, and it will be equal to a call in the Pickle module to the load function. And we are loading, the argument of load is where we're loading from. We're loading from TOF, the open file. Now the file has been read, and the value of what was read there is now stored in the variable data. We want to get in the habit of closing our files immediately after we have used them or completed using them. And if this was successful, then we ought to be able to print data and see what was in that file. I'm going to save and run. I have to spell the data file correctly if it's going to recognize it. And I can see that I went through the process of opening, writing hello files, closing, then opening again in read mode, reading it, putting the information into data and printing data, which was the hello files that was stored. And to make a note, this only pickled one thing. We could pickle as many things as we wish, but each would require a separate call to dump. Dump is the function that saved our string. And if we wanted to save more objects, then we would need to call dump and save more things that way. Loading would require as many calls to load as there are items to load in the file. Pickle stores the data in the same order it is dumped. So in loading, it must anticipate that same order. Fortunately, entire data structures like lists and dictionaries can be stored as single things. To better exemplify this, the following is a set of simple functions that can be called to save and load two items. So two functions have been written, one called save, one called load. Save will take two values assigned to the variables data and data2. Save goes through the process of getting the path, opening the file in write mode, and then dumping twice. So those two values were put in one after the other in a particular order, and then the file is closed. This function will save or pickle any two things that are sent to it. And then the load complements that. The load function repeats the process that we've seen before. It gets the path. It opens the same file in read mode. It assigns a variable a call to load, and then a second variable a call to load because two things were dumped into the file. So we need to, if we're going to get all of the contents that was there, we need to load twice. And it will be loaded in the same order, or the values of data and data2 will take on the order of which we dumped the information. And then we close the file and we return the two values that we just loaded. So we can see this being used with this code here. Making use of the save function first. So we have a family name, a variable that is assigned Zisnovec, and a list that has 4 strings in it. We call the save function sending these 2 values to the save function. The save function anticipates taking 2 values. Notice that family members is a list in itself. So we're going to store 2 things. We're going to use the save function to dump a string and then dump an entire list. If I save and I run, I don't see anything, so we're going to assume that the example file that was opened by save now exists on my drive. I can check for it, and that there's something written in that example file. Looking for the example file, I can see it's there. It wasn't there before. Though, no, it was there before because I didn't have these commented out, and I think that I had a previous call to save. So it might have been there before, but now it's rewritten if I just used it. And the second thing I'm going to do in these functions is I'm going to load that information and see if it retrieves what I expect. But before I do, I'm going to comment out that save. The new code will call load, and what is returned by load is going to be assigned to be these 2 variables, name and members. And if I got those values, name and members, I'm going to use them in a print statement. And if members is a list, I'm going to iterate through it and print every element in the list members as person. Now in this case, when I save and I run my program, there is no creation and saving of this information. So if this is going to work and we see this information printed so that the user can see, it wasn't because it was previously defined in this program. It's because it was successfully saved before, and now I'm loading it in order to get that information that I expect to be Zisnovec and a list of names. Let's see. I do get that information from the file, and we can see that it's been printed out. And finishing up, note that the variables that were assigned the information do not need to have the same name. It was the family name when initialized, data inside the function, and name when it was assigned after the return. In other words, this is pointing out that what we call the variables in different places in our programs, in different namespaces, doesn't need to be the same. What matters is the value. So this is pointing out that when family name was saved, the value was Zisnovec, but it was the variable family name here. When it was sent to the save function, it was data that had that value Zisnovec. And then when the load function got it, it was still data, but when it returned data, it returned it to this line and called it name. And finally, now you. You have seen how you can easily store data on a computer with the Pickle module, and 2 easy-to-use functions have been defined for you to make use of. Write a simple program that begins by copying the save and load functions written here. Rewrite them so that they only pickle 1 thing instead of 2. Practice making use of them by saving something and then verifying by loading it and printing. Have fun.